Good morning, everyone. Myself, Tanuja, Assistant Professor from Allareddy Engineering College. I'm here to give you an online lecture from Principles of Bridge Engineering, the Module 1, Types of Bridges, a Basic Bridge Introduction, and Classification of Bridges. So, here let's go into the topic directly. Okay, coming to the principles here. So, let us talk about a basic introduction to the bridge. A bridge is a structure which is built over some physical obstacle, such as a body of water, valley, or road, and its whole and sole purpose is to cross over that physical obstacle. So, here the idea of the bridge came from uh, in olden days, people used to travel from one place to other place, crossing over various obstacles. So, if there is some deep water body or if there is some deep valleys, in that cases, people used to have some like wooden logs or banyan tree branches as a support to cross over that obstacle. Hence, that is the way the idea of the bridge has come into existence. So this bridge, it is built itself strong enough to support its own weight as well as the weight of anything that should pass over it. Hence, a bridge is a structure, it maintains some communication over that physical obstacle. That obstacle can be a channel, a river, valley, or roadway, or railway, anything. Now you can see some various pictures of different obstacles where one person has to travel uh, distances. These are some of the components of a bridge. The superstructure comprises of deck, truss or girders, and the substructure comprises of piers, abutments, and bearing and foundation. So we can see the various components of the bridge here. So the superstructure, that is the deck that is being carried by various beams, and below that you will have a bearing, and to that we'll have some cap beam. A cap beam will be supported by various columns that are piers, and the rest will be transferred to the foundation. So coming to the classification of bridges, bridges are mainly classified according to three main types. Okay, so first classification is about materials. What materials which are used in the construction, what are its various structural forms, and what is the purpose of the construction and the basic function of that particular bridge. So coming to the classification according to that material, we have four different types of materials that are being used: timber, masonry, concrete, steel. Like this, there are various materials which we categorize them into. Now, coming to the timber or wooden bridge, so you can see a Swedish bridge. It was an olden construction. It is supported by masonry, and it is not. It is only used for light motor vehicles. This is the arch bridges. So this is a completely masonry bridge. You can see how elegantly it has been portrayed. Arch bridges are one of the most beautiful bridges that can be seen ever. Next is precast and pre-stressed and pre-tensioned. So these are everything is RCC slab bridges. So this is one of the famous and the most strongest bridges that we can say, which has the least maintenance, and we can say that it is most efficient bridge. So this is a steel bridge. So steel bridge is built over a steel structure. Okay, and these steel bridges, they carry load, shear, and flexural bendings. So these steel bridges are built on a water body. The major disadvantages of these bridges is they can be easily get rusted because it is more of maintenance works that has to be done for these kind of bridges. Now coming to the various structural forms. So there are slab bridges, beam or girder bridges, and cantilever or balanced cantilever bridges, and the box girder bridges, which are again known as cellular or multi-celled bridges. So there are truss bridges, arch bridges, cable stayed, suspension bridges, which are spanning from 35 meters to 2000 meters total span. So now coming to the distinctive features of the slab bridges. So it is usually used for very short spans because the slab bridges are mainly meant for very shorter areas where a small obstacle is very small, and if they have to pave a way using a highways or something like that, slab bridges can be used. They carry loads in shear as well as flexural bending. They have sufficient torsional stiffness, and bearings are highly not required here, not required, and simple shuttering or formwork will be sufficient. So they become heavy if there is any larger spans. So hollow slabs are mostly preferred for these kind of bridges. Next, coming to the distinctive features of beam or girder bridges. This is one of the oldest and most common bridge type known. So it is usually used for short and medium spans. They carry loads in shear and flexural bending. So in modern, we can see that these girder bridges and steel I-beams, they replace these concrete beams. They carry the low torsional stiffness. Now coming to the pictures that you can see, beam and girder bridges with various types and various forms. So these are distinctive features of box girder bridges. So in addition to the flexural stiffness and shear resistance, these bridges have sufficient torsional stiffness as well. These are more suitable for curved plan and longer span bridges. So you can see the pictures here. The very famous metro rail bridges are all precast bridges only. So they are segmented at some precast yard and they are being getting installed. So in between them there is some epoxy glues that have been laid, and in between there will be some holes, hollow sections. In that hollow sections, the pipes, the tendons will be passed, and the tendons are tensioned and jacked with a hydraulic jack, using a hydraulic jack, and these perform good in tension as well. So they gain good connection and bonding between all the cells or segments. Now coming to the truss bridges, the primary member force are axial loads here. So these truss bridges, they carry most of the axial loads. Here the open web system, it permits the use of great overall depth than for an equivalent solid web girder. So hence there will be some deflections which are reduced and the structure will become rigid. So both these factors, they lead to economy in the material. So you don't have to use entire material, because wherever the places where you're getting more deflections, those places we are providing the material, and hence the dead weight is also reduced. So the main disadvantage here is it has high maintenance and fabrication costs, and as well as people, they require more skilled labor and skilled professionals while performing this job. So the aesthetic appearance will be exceptionally beautiful, and the span range, which is economical up to 300 meters. So you can see various types of truss bridges like Hove truss, Pratt truss, Warren truss. So number of bridges, they can be used for multi-purpose also. So up there will be above on the top, you can use it for railway, and below you can use it for roadway as well. Next is cantilever bridges. In cantilever bridges, it can be of steel or concrete. So here the roadway is constructed out from the pier in two directions. Hence, the only one single pier will be resting the two sides of the slab. That is where it is called as a cantilever bridge. So that the weight on the both sides will be counterbalanced here. So it cannot be on only on one side. As we all know, cantilever is only supported on one side. So if there is some counterbalance on two sides, there won't be any overturning of that particular bridge. So this cannot be used for larger sections. because it cannot support negative moments. Next is arch bridges. These arch action, it reduces the bending moments. It is economical when compared to simply supported bridges and truss bridges. So it has, when the site is deep gorges with steepy rock banks, then these arch bridges come into picture. So the conventional curved arch rib has high fabrication and erection costs. So they can be built from stones, and these are the most beautiful bridge types. They can be used in the span range of up to 250 meters. As you can see in the picture 3-inch arches, 2-inch arches, and sloped arches. So like this, various arch bridges have been constructed all across the world. Now coming to the suspension bridges. So this is also the most famous suspension bridges. The cables carry some of the tension and they will be resting on the abutment. And these wires or cables, they will be tied to the abutment. Hence the abutment should be massive. So the stiffening serves the aerodynamic movement inside the bridge. So the loading will be like from when the load falls on the bridge. So the suspenders carry the load from there to the column and then to the foundation. So like this, the loading pattern will be carried over. So these height of the main towers is the major disadvantage. If there is any approachable airport nearby, so it can be a disadvantage there. So generally it spans over up to 600 to 3000 meters. So you can see various suspension bridges, which is an age old procedures. Next, coming to the distinctive features of the cable stayed bridges. So you will have concrete box bridges and steel box decks, steel truss decks. So here tendons are exposed outside of the beam. That is the major difference between suspension and cable stayed suspensions. So these individual cables, they are shorter than the full length of the superstructure. Hence, they are normally constructed of individual wire ropes supplied completely with end fittings, pre-stretched and not spun. So this is economical over 200 to 500 meters. Next is suitability based on the span. So now you can see how which bridge is suitable for which span length and all. So if we take on x-axis, if we do span length, and on the y-axis, if we take types of the bridges, so we can see how much there will be a difference. If the span length is more, we can go for steel suspensions. So I hope you understand the topic carefully